Welcome back to another HVAC-Engineering-Techie training video. Today's subject matter is technical commissioning of plumbing systems. Now, plumbing systems don't get a lot of activity with commissioning, but they should, especially those systems that have complex systems within them should actually be commissioned. So this will take you through the process, how you actually do that, and what you should be doing. And I hope you appreciate this because this is one of the alternate systems within the commissioning world. So remember, this is the channel that talks all things building systems, HVAC, controls, test and balance, plumbing, electrical, fire alarm, all of those systems within a building we will cover. So appreciate you being here. I really appreciate you being a subscribing member. If you're not a subscribing member, I'd really appreciate it if you become one. All you do is click that subscribe button down below. Give me a thumbs up if you like the video. This is absolutely free, costs you nothing. I will never bug you. No one else will ever bug you because you do that. But what it does is Google uses that data to evaluate my videos, which keeps me on the air. So I'd really appreciate it. All right, let's get started on technical commissioning of plumbing systems. So the first thing I'd like to do is take a look at the plumbing system training sessions we have available. And this is for people who aren't real familiar with total plumbing systems. And this will be material that can get you up to speed. First, we have a D12 plumbing system design. We also have S35, which is sanitary waste and drainage plumbing systems. S36 is plumbing domestic water systems. Get you up to speed in all the different kind of systems and their components. S37 is plumbing special systems, which includes fuel systems, compressed air, steam system, medical gas, swimming pool and fountains, and process and plumbing control systems. And Cx-14, which is technical commissioning of plumbing systems, which is today's video. So we're going to go through how you actually commission plumbing systems. And so this will be an interesting go through because traditionally, plumbing has gotten very little commissioning, which is unfortunate because it actually needs it. So let's get started. Plumbing systems are commissioned in the same basic manner as HVAC systems. Plumbing commissioning, the main emphasis is on pre-functional tests, PFTs, and operational performance tests for startup of the systems. Plumbing systems that have control systems or other exotic sequences also require functional tests. So the systems that we include, basically are sanitary waste and vents, storm drain systems, domestic cold water systems, and hot water systems. Pure water systems, reclaimed water systems, gray water systems, site well water systems, fuel systems, compressed air systems, steam piping systems, medical gas systems, and process pipe systems. So there's a lot of different systems that might be considered and be in a part of your plumbing system and plumbing control systems. Commissioning provider, the CP, for commissioning provider, creates the CX plan. CP performs the CX design review. CP holds the CX kickoff meeting. CP performs site inspections. Contractors perform document ready for startup PFT sheets, and we'll get into this in a little bit. Contractors perform a document static test. Contractors perform a document PFT startup test. Commissioner and contractors perform a document functional performance test. Contractors perform owner training. The CP provides the CX report. CP provides a system manual. Now, the way it is in commissioning, all of these different aspects can be included or not included depending on what the owner actually wants. But this is the basic process, and this follows the basic commissioning process of the standard S110. And if you need more information on that, go to our training video CX-1 and CX-2, and they'll lay out the basic process of commissioning, and this basically follows that procedure. Oh, and perform the warranty report. Don't forget about that. And this is the pre-construction process, right? These three here, these here are done during the construction process. These are the final things we do for a system acceptance, and this is all the documentation that takes care of that. So plumbing system prior to design. So before the system actually gets designed, now a lot of times you're not hired as a commissioner until later, but this is when you really should be. To give maximum effect and maximum benefit, this is the actual time to start. Define the scope of the work. So you have to get with the owner and say, what do we want to do? What systems do we want? How deep do we want to commission? What aspects of commissioning do you want to apply to this system? Commissioning scope, commissioning contract, you got to get a contract if you want to get paid, so you need to do that first. And then the owner's project requirements. The owner needs to develop the OPR, which is the owner's project requirements. This is actually overlooked sometimes, and everybody thinks it's just a work requirement I have to do, so just throw out a letter and tell what it is. No, that's unfortunate, because this should be exactly what you're telling the designers and the contractors of what you need and what you want in this job. And if you don't do that, you get what you get. You might get whatever piece of equipment that the rep took the designer to lunch, so he gets his equipment specified. You don't want that. You really want what you really need. Owner statement of building expectations, system types, description of characteristics, sustainability expectations, standard plumbing construction materials, standard products and brands, special plumbing equipment, budgets. All that should be in the OPR. It's what keeps your job on track, and you really need to provide that. Create the preliminary commissioning plan. That's done by the CP. Defines the commissioning phase. Creates the issue log to know what an issue log is going to look like, and define the system manual requirements. Facility operating guide. You got to define what that's going to be. Submittal and shop drawing required data. Final OPR. And a BOD, final drawing specification, O&M manuals, training records, and documentations. So plumbing commissioning and design. One of the major benefits you have by hiring a commissioner early is you get to do a commissioning review of the design, which is really, really helpful. It's not that the designers are doing a bad job, it's just you want to make sure they've included everything they need to, that they fully communicated the design. When they don't do that, the construction cannot go well. So we need to have a fully communicated design, and there are standard ways of doing that, and I will show that to you. Plumbing commissioning of the design. Design the kickoff meeting. Review the design commissioning process with the engineers so they understand what's going to happen and how they can be beneficial in that, and how to make it easy for themselves. Review the preliminary plan. Review the communication protocols. How are we going to communicate with each other? Ask and answer any questions. Now, in this design kickoff meeting, it's you, the owner, and the designers. So that's a pretty easy mix. If it happens to be a cement risk, then the contractor will be involved. But if not, if it's a design build, then it would be owner, the commissioner, and the designers. Review the basis of design. Design team's input or response to the OPR, the design narrative, the design criteria. Now, this is a challenge because a lot of engineering firms don't fully understand what this is supposed to be. And this has been around for years, and this has been, 100 years this has been around. And they still don't get this right. And it's unfortunate because it's a process that improves their process, and they should really go through this, and I'll explain it. So you want to make sure they create a BOD, and to do that, this is what happens. The design narrative includes preliminary sizing calculation, water, sewer, and storm, alternative system type analysis. So the engineer is supposed to put a narrative together that says, okay, this is what I did. This is what size I say. Here's the calculation for the sizing. It's calculation for the pipe sizing, all that. Here's the alternate system type analysis. I analyzed what systems would be the best in a specific application. I chose this because, and I rejected these others because. So now the owner can fully understand why the design looks like it does. So storm, exterior, interior, overflows versus scuppers, that sort of thing. Fixture, tank versus flush, water supply, maintenance issues. So all of those kind of things. Those are just a couple examples. Preliminary one-line layout, so real preliminary. This is basically where the line's going to run and all that stuff. And what this does, this gives the owner a chance to look at it before the design's actually done. And this becomes very beneficial for the designer. Because what can happen is the designer can make a decision, I'm going to do this, and the owner can say, oh, no, we can't do that. This has got to go this way. Okay, now the designer has to do it again. So this is actually a money-saving thing for the designer. Consideration of potential LED credits in system design. What sustainability level are they going to do? The design criteria is a methodology of design parameters, identify design performance and limitations, sizing parameters, water, storms, size or utility usage, maintenance capability, safety factors. So all of this stuff is his design criteria. This is stuff you're not, as a commissioner, you're not normally involved in, because this is what he's saying. These are what back up my design. This is how I actually do it, and the owner needs to approve this stuff. And levels of redundancy. So then, as a commissioner, you're going to review the design. A review of the design parameters at each phase. Schematic design, 35%. Design development, 65 and 95. Construction documents, 100%. This is what it should be. You don't always get the opportunity to do everything, but schematic gives you an idea of what's happening. You don't get much input there, but at least you can get some. Design development is where most of your work is done. 65% is where we should have specifications. We should have everything identified, major equipment identified, what we're going to do. And of course, the 95%, all the duct and piping and everything in the system will be complete. And full construction documents, and you're just making sure that they addressed the issues you brought up. If not, you need to get the owner involved because they're ignoring you. It's not unusual for designers to ignore us commissioners, but if it's really important, it's something we need to really pay attention to. Issue log a design team response. CX specifications of creation or review. In other words, the design documents need to include a commissioning specification for the contractors so the contractors understand what's expected of them through the commissioning process. This is important. It's not fair for them to not know that when they're bidding a job because they need to add dollars for meetings. They need to add dollars for some site activities they may normally not do, but they need to do for commissioning. So that needs to be in the specification. Well, it is much easier, I'm just telling you, it's much easier for you to give the specification to the designer because it matches your processes rather than try to review the spec the designer has created, which may not match your processes at all. So the design review process of that is problematic for you. It's much easier to give them the full spec. Draft commissioning plan. So you have a commissioning plan drafted so everyone understands what that is. It's created by the commissioner. A design review. It's not a peer review now, and we do have a couple of associations out there that call it peer review, but it's not. A design peer review is a review done by a peer, and it's done for the engineering process. Did he do this correctly? Did he use the right process? Did he do this correctly? And those are things that you don't really care about. You care only about the results. You care about the documents. You care about what's being provided to the contractor. So it's a much different review. It's a commission review. It's much different. Normally a review of load calculations, equipment, and pipe sizing are not done for a plumbing commissioning design review. Normally you don't do that because that's part of what a peer review would look at. You don't do that. You're looking at all the other things beside that. So what you're looking for, so normally you use the OPR and the BOD information to do this review. You want to make sure what they came up with the final design actually matches what the owner actually required and what the engineer said he was going to do. So you need to look at those two things. Normally it's called a cursory plan review. It's where you look for obvious errors, coordination errors, or items that do not meet the intent of the OPR. This is not hard stuff to do. You just want to make sure in general it's got simple things. And then every once in a while, if you find an issue that pops up that you actually need to go look at pipe size, then you might do that. I've seen it several times on water where it makes no sense where a 4-inch main feeds 3 other 4-inch mains, and you go, wait a minute, this doesn't feel right to me. And you got to check that out to make sure that the pipe sizing is done correctly. Verify what the design is adequately communicated to the contractors. You know, I have this old saying, and I've said it many times before, if you show a system exact perfect on the drawings, this is exactly how it should be, you have a 50-50 chance of actually getting it installed that way. But if you make a mistake and show it wrong, I guarantee the contractor will install it exactly like you show it. It's just kind of Peter's principle kind of thing. So make sure the design is actually communicated correctly. Look for items that will affect. Okay, now what I mean by the design is being adequately communicated is it means that can the contractor actually build this correctly from these drawings? If you can't figure it out, a contractor won't be able to figure it out. So that's what we're trying to say. No confusion on the drawings. Look for items that will affect operability, functionality, maintainability, commissionability, and industrial best practices. So those sound like big funny words, but basically you're trying to make sure this is actually going to work and the people operating can actually make it work. So that's your job. Design codes and compliance. ADA compliance for handy access, wheelchair clearances, stall doors and widths, number of handicap fixtures and grab bars, number of handicap drinking fountains, NFPA 99 standard of healthcare facilities, NFPA 54 fuel gas code, ASPE handbook, American Society of Plumbing Engineers, national plumbing codes, and these may be the codes that they may actually use, or local adapted plumbing codes. And these should all be exposed in the design criteria or in the specification, so you know what basic codes underlie what we're doing. Design review issue log, the log plan and specification issues, obvious plan omissions or incorrect layout or details, specification omissions or contradictory specifications, change for communication of the design. Always put in the form of a question. When you're doing an issue log, statements can get people irritated, so instead of that, just asking a question. And you had a guy work for me, and I told him that, and so he just put a why in front of her. That's not what we're asking about. You're asking a question, is this really supposed to be this way? I've seen it, and you explain why you're doing that, why you're asking that question. Because I've had an experience of doing this way and it didn't work, and here's what happened. So maybe we need to relook at this. So things like that. So you're asking a question in a way that's not confrontational to the designer. You don't want that. You want a designer on your side. You're trying to help him not use his E&O insurance. So he needs to understand you're actually trying to help. Separate design and construction issue logs. Separate design and issue logs on design and construction. A lot of designers do not want, if we had a discussion about issues, something that was an issue, we've discussed it, and we have a plan change, they don't feel comfortable with the contractor seeing that area in case it might impact their ability to get a change order. So the contractor might say, hey, look, we can get a change order because they did it this way, this affected this, we can maybe get a change order on this. So basically, it's not unethical. It's just the designer needs to keep his business separate from what the contractor is going to do. And this is just an example. Now, in my commissioning business, I used all Excel and Word forms, all paper forms. But you can use an automated piece of software to do this with the same thing, where this is the issue, these are the dates, where it's at, whatever, and this is the actual description of the issue. And then you put a place on this side for the designer to respond. And you put the date of his response and who actually did the responding. And because what happens a lot of times in issue log, you'll cite an issue, and the designer will come back and say, I don't agree with you. I don't think this is an issue. You say, okay, that's fine. Remember that the designer has the authority, not you. As a commissioner, you have all kinds of responsibility and absolutely no authority. So you remember that you're always working through somebody else. Well, if you say, this is actually a real problem, you may have to take that designer's response and go to the owner and say, look, we have a problem because this is actually a problem, and explain it to him. And then the designer, because the designer works for the owner can actually get this affected. Or you may make an issue that say, I think this is an issue, and the designer said, no, I've done this many times, it works just fine. And you have to say, fine, not a problem. If it's not a serious issue, it may just be a way you don't like it, you prefer some other method, but in the end it works. It's not for you. This is not about you being a designer or you about you. It's about getting the best design for the facility. So plumbing consists of construction. Well, we got through the design phase. Now, prior to commissioning, the CP must obtain the following items. You got to have a copy of final plumbing drawings and specifications, copy of all shop drawings and submittals for plumbing systems, copy of all as-built drawings of existing construction, rough-in sheets for all plumbing fixtures, rough-in sheets for owner-supplied equipment, so all this stuff should be coming in from the submittals. Copy of the contractor's schedule, know what his schedule is going to be. Then you create a commissioning plan. Now, the commissioning plan is similar and maybe the same as the designer's plan, but it will be extended. It'll have a lot more data, a lot more detail because it includes the actual construction. Complete team member contact data, complete commissioning check sheets and forms, installation and inspection forms, startup test forms for operational functional performance test scripts, final duration schedule for commissioning work, CX submittal review. CP performs concurrently with the design team is the preferred method. You can actually do it post. The submittals can be approved by the engineer, and then you can look at them post. That's not a problem. But the problem is when you do it post and you find an issue that the engineer missed, then it's going to go back to the designer to be reviewed again, and that's okay, but it does a little irritating for the designer, and the contractors now are delayed a little bit as that process goes on. Concurrently, it works better because you find an issue and you report it, and the designer looks at that before he finishes his, and it makes it seamless. So there's one iteration to the contractors would actually improve the process. And your review of the submittals is much easier than the designer, so you should be able to do that fairly quick and get through them. One of the big problems about submittal review is when you have jobs where the submittal review doesn't ever get done or never fully completes. That's tragic, and that the owner and the general contractor should never, ever allow that. I mean, I worked recently on a job, huge hospital, and the submittals kept coming in clear to system startup. How can you possibly do that? Some decisions, so the engineer and the commissioner, me, basically did submittal reviews forever on the job. It was ridiculous. I mean, it was the contractor did submittal reviews by area, did submittals by area, and by items. So basically, you'd get 10 submittals, all exactly the same, for different areas at different times, which is ridiculous. So that was a problem. That should have never happened. You're going to check on your submittal review material, size, capacity, weights, and installed access space, electrical characteristics, accessories and options, accessibility for maintenance repair, controls and control integration, used for check sheets creation. One thing I've always looked at this stuff in a plumbing one, you want to make sure your pressure systems are correct and your temperature systems are correct. This is not really hard on plumbing. It's much more difficult than HVAC. But it's not. Issue log and design team response. You manage that process. Pre-functional tests. Okay, this is where the irritation starts in that the PFT test consists of two parts. The first is ready for startup inspections, and the second part is the actual system startup verification. Now, why I don't like this is originally we called them something else because they're actually two separate processes. But ASHRAE, in its infinite wisdom, decided that they were one test, and they called them a pre-functional test. The name's fine, but now you need some way to define the two, so I've just named them what they are. You have inspections to make sure this system is ready to start up, and many manufacturers require that, so that's one pre-functional test. And then when you actually start the system up, that's another pre-functional test. It's not a functional test, it's a pre-functional test. So, okay, get on my soapbox, but that's why there's two different things within the PFT. Both of these activities have an associated verification check sheet that the contractor fills out to indicate the work has been completed. The contractor also includes any pertinent set point pressure flows or electrical data readings indicated during the startup process. The manufacturer's startup documents may be attached to the startup PFT. Because a lot of times the contractors are obligated to do the equipment, the manufacturer's equipment startup, because that's part of their warranty process. And that's fine. We just want to take that data that they did for that one and put it on our check sheet so it gets into the report. The owner actually gets his hands on it. Because what happens with these manufacturer startup, they don't normally get to the owner. And that's not what we need. We need that startup data. We want the operator to be able to see what a system looked like when it was first brand new. And to do that, we need this data. Normally, the CP provides these check sheets, but they may be created by the contractor if desired. Depends on the process you're using. It doesn't matter who creates them, just as long as they get created and used correctly. Now, check sheets are a disaster on some projects where the contractor says they're worthless. They're just a work ethic, so I'm just going to fill them out in the trailer. Or I'm going to use a pre-apprentice to go check everything out, which is nonsense. I mean, you need to, if you're a contractor and you're proud of your work, you're proud of your quality, then you make sure. When I was a contractor, I learned right away that the most experienced person did the inspection. Maybe me out there doing the inspection because I wanted, it was I was a contractor, it was my name on the line, and I wanted the job right. So I always inspected the job prior to letting anybody else inspect the job, so that I already had a list for my people to fix stuff before anybody else ever looked at it, because I wanted my jobs to be as perfect as they possibly can. All check sheets are always completed by the contractor and viewed by the CP, so it's really important that you help the contractor to understand this is his quality process. If he turns in a check sheet as a pile of crap, then that means he's that kind of contractor. So you want to say to the contractor, this is your demonstration of your quality. And so if your quality's low, then you're going to do a low process of this check sheet. Don't do that. Make it worthwhile. Check sheets required by equipment type. Pipe systems have field inspection only. Plumbing equipment and fixtures have PFT ready for startup, and they have PFT startup tests, 2 different ones. Plumbing systems with control sequences can have an FPT also, and startup system test, and FPTs. Oh, I labeled this wrong. This should have been a PFT, not an FPT. Sorry about that. Typical systems for PFTs are all plumbing fixtures and trim, pressure booster systems, hot water boilers and heaters, temperature mixing valves, water ozone purifiers, water softeners, RODI systems, sump pumps and sewage ejectors, trap primers, irrigation controllers and systems. Typical systems for FPT: pressure booster systems, touchless faucets and flush valves, hot water temperature control devices. So you can see there's not many functional tests. That's why plumbing systems are much easier than HVAC systems, which have a lot of functional tests. Creating the pre-functional check sheet. Check sheets are created from submittal and drawing data. They are intended to be a list of items the contractor must verify for the equipment or system to function properly. 1 check sheet per piece of equipment per each type of PFD, ready for startup. Startup PFDs. Manufacturer requires startup documents may be attached. The equipment must be started up and must not be started up until the ready for startup inspection report is revised, reviewed, and approved. Because if the guy runs out and does a startup without inspecting it it's not ready for startup, then it will either damage equipment or not be a successful startup. So we want these intended. Now, one of the hardships of commissioning is actually trying to manage all this process. And this is even if you have a piece of software doing this for you, it's an automated piece of software, because you have to continually check to see what's done and what's not done. It can become problematic. It becomes a general topic of commissioning meetings. Functional tests are not performed until the startup test check sheet is reviewed and approved. Now, by approved, I mean that you have it and you say it's been done. You can have an official approval process if that's the way your job is. Normally mine was not. It was just I would tell them that it's not, and I would be communicating with the general contractor that way. Check sheets may be paper-based or completed through a software solution. This happens to be a paper-based one. It means nothing. It's just how mine looked at, just to give you an idea. And this is the header data goes up here. This is the test information when it was done. This is the check sheet. This is the items you want him to check as he goes through. This is the submittal data. And you put data here so that the guy that's actually doing the field can look at the data to make sure it's the right piece of equipment. If you don't do that, you don't know what it is. So you want to make sure you have that data in here. And then this is the field verification data. This is where he actually fills in what's going on. And I always told the people, I don't want you putting a check mark, and I don't want you saying, okay. I want you saying, I have verified this. Or if it's a test, like a startup test, you actually put the data in, the actual data. So, if it's a 480 volt system, I don't want to write in 480 volt. I want to know what the voltage is on every leg of the unit. So I should have 3 readings that are all slightly different. And that means that someone's actually put a meter on and read them, and I want to see that. I want to see the current on each leg. And so that stuff is data that the operator actually needs. And issues down here, we put issue notes. So we have a question. What happened here in issue? Which means there may be 2 or 3 iterations of this report, but at least you're able to do that. And the final thing is a verifier's signature. In that effort to help a contractor do a quality job, we want to know who the guy that actually filled this out is. And we like it legible, not just a scribble of a name. Don't know who that is. So we'd like that on these check sheets. The other thing I have to say is you need to look at this as we go along. You don't want to wait to the end of the job and get a check sheet and realize none of this is done. You need to see it as we go along. A startup test, the same thing, except it has slightly different data because it's actually a startup sheet. So it's got header data here. It's got the test information. It's got the check sheet data here. It has the actual submitted data here. And then you put the verification in here. This is set up to have 3 legs for each one. This happens to maybe voltage. This one was volts, amps, and then VFD program, different things like that you want to have in the check sheet. And then, of course, we had the issues progress and the verifier signature, just like the others. Construction kickoff meeting. The meeting content should be review the plan, review the check sheets by trade, review functional performance test requirements, answer any questions. Meeting attendees should be the CP directs the meeting and provides minutes and reports, minuets, minutes, figure that out. General contractor representative, owner's representatives, engineer representatives, plumbing contractors representative, plumbing subcontractor representatives should all be present. Contractors perform static tests, underground pipe slope verification test, underground and above ground pipe hydrostatic test, piping pressure test, gas pressure test, medical gas cross-connection test, backflow preventer test, chlorination stabilization test, sterilization test, irrigation sprinkler system test. These tests should always include 100% no sampling strategies should be utilized. Now, sampling strategy just means you want something to fail. So we want to test everything. And this is not hard to do. This is the code required static test. You don't do these. The contractors do this. And normally as a commissioner, you don't witness this either. And the reason is because you're never there when they need this. They need these daily on the site. And if you're not there, you can't do that. So normally we assign witness authority to the general contractor to verify these were done. CP performs field inspections and observations. Contractors complete the check sheets. Ready for startup and, of course, equipment startup. Okay, site inspections. We'll spend a little more time here because this is something that you need to do and you need to be good at. What are site inspections? Coordinate your site visit with the contractors. They need to know you're going to be there. Perform a walkthrough of observing system installation and create a construction issue log of all deficiencies observed. Observe the percent complete of each system. Observe readiness of system for startup tests. Hold a site CX meeting if needed. Now, why do you observe the percent complete of each system? What happens is a lot of times you will do a site inspection and you get a feel for really where the job is at, what percent complete we are, how much equipment's installed or whatever, and then you go to a contractor's meeting and the contractor said, well, we're going to finish this area next week. And everyone just says, okay. And you look at him and say, you can't. The equipment is not installed yet. You cannot finish next week. There's too many things that have to happen. And the contractor will be very surprised. He said, well, they've told me it's ready. Well, it's not. And you have to be the back check for that because it's a problem that happens a lot in the industry is the subcontractors don't stand up for themselves and don't defend where the project is against the general contractor. Because the general contractor may have, visions of grandeur or visions of being able to do something that's not possible, and you need to make sure you're the guy with the reality. When should site inspections be done? Site inspections should start when plumbing piping is started being installed and end when all fixtures are complete. Site inspection frequency will depend upon the size and schedule of the project. Normally, site inspections are done monthly, semi-weekly, or weekly. On very large projects where there are many locations at different stages of the inspection process, installation process, daily site inspections may be required. Now, that's a problem. That means you would have a person on site full time. I've never actually had a job that way. Even though I've had some very, very large jobs, we've always been able to do them on a monthly basis or a semi-weekly basis. So we may have an inspection monthly, but we have test schedules at other times. And so basically you have that at different times. At a minimum, installation must be inspected prior to covering work. So you can't allow any work to be covered unless it's been inspected. How to be prepared for site inspections. Perform all required in construction document review prior to the site visit. Review of construction drawings. Review of equipment and system submittals. Review past issue logs and each issue status. Review last site CX meeting notes and action items. Verify that you have all required site safety PPE, including hard hats, safety vests, hard-toed boots, safety glasses, gloves, hearing protection, and fire-safe clothing. that you need to have every time you go there. Verify that you have attended any required site safety training. So if the contractor and owner require certain training, you need to be, or any of your people need to have attended that training prior to you being there. Verify that you have all required inspection tools. A camera. Your cell phone is fine if you got it. You got to make sure you have it. Flashlight, tape measure, notepad, electronic, plans and specification, electronic, hopefully. You can have this in paper if you want, but this is the stuff you need. Flashlight is important, so if there's a dark area, safety may be an issue. You need to be able to have there. You have a tape measure to make sure you can measure something. And you need to have a camera that will actually work for what you want to do. Sometimes an iPhone may not work. It can work, but this doesn't do what you need to do. It may not have enough zoom, or may not have enough width or enough light capturing capability of the lens to do the job, but normally they do a really good job. Inspection safety, always be aware of your surroundings. One of the problems we have with inspections is you're fully concentrated as you walk around, you're not actually looking where you're going. This is especially true on roofs. So if you're up doing roof drain inspection, be very, very careful that you don't get close to the edge. I mean, I sound stupid, but you get so caught up in what you're doing, you do forget where you're going. Be very, very careful. Always ask for permission to use someone else's ladders or scaffolding. They're not yours. You may need to build your own ladders, that's fine, but if someone else will let you use one, that's fine also, but you need to ask. Always obey contractor's request to delay an inspection or leave the area. If the contractor says, we've got to do something, you shouldn't be here, you don't have the right safety PPE for that, leave, because they're responsible for it, so you need to do what they tell you to do. Answer questions when asked. Always warn of an unsafe condition or life safety issue, even if it's not for a system in your scope of work. So a couple of things here. Some commissioners like to direct contractors what to do. You should not do that. They do not work for you. You do not have that authority. If they ask, you can certainly tell them what's the right way to do this. Or if they ask why you're asking that, you can certainly do that. You know, you're trying to be a friend. You're trying to help them out. But at the end of the day, they don't work for you, so they should not take direction. You should go through the normal communication process of commissioning. Document the issue, explain the issue, take a picture of the issue. Very, very important. Contractors will argue with you all day long on a paragraph. They don't want to argue with the picture. Picture solves the problem right there. Remember, safety is everyone's responsibility. Observe percent complete of piping area. This is what to do for sanitary waste and vent piping. Verify pipe systems generally match the design drawings. If it is not unusual for addendum drawings or system revisions to not be forwarded to you. I don't know why, but it's irritating. It does happen. So there may be a change that you don't have. So it gives you a good wake-up call to go get the change. That's important. Observe pipe hangers meet specifications, and pipe trees are secured to the structure and are not movable. So what you do is you walk up to a pipe tree and shake it. If it moves, that ain't right. It needs to be secured. So if the wall's not been put up yet, don't do that. But if the wall's up and the pipe's in there, but it's not secured to the wall, you need to shake it. Some people seem to think that the freestanding pipe will just take care of itself, and it won't. It needs to be secured. Observe pipe system are installed with correct slope. Verify that required hydrostatic pressure tests have been performed prior to closing walls or ceilings. Observe the trap primers or trap seals are installed in all floor drains and floor sinks are as specified. Observe that required fixture carriers are installed with correct dimensions for correct fixture placement. If it ain't correct now, boy, it's going to be a problem later on. Observe that storm drain piping is installed and properly supported. So what to do for water pipe inspection? Kind of observe the percent complete by area. Verify pipe systems generally match the design drawings. Remember, you may not have the main addenda. Observe pipe hangers and meet specifications. Verify that corrosion isolation is present on all copper pipe hangers, clamps, and supports. Remember that copper and steel don't get along. You can't let them touch. Observe valves and pipe specialties are installed and are correct per the application. Verify pipe and valve labeling is complete per specification. Verify thrust blocking is installed on underground piping. Verify the required pipe pressure tests have been performed prior to installing pipe insulation or closing walls or ceilings. Verify that pipe flushing and sterilization have been completed. Verify pipe lighting and valve tags are installed as specified. Verify trap primers are installed as specified. Verify water pressure specialties or water pipe specialties are installed as specified. What to do for plumbing equipment inspection, same thing. List percent complete by area. Observe fixture on the correct fixture and install correctly. Observe that all touchless faucets and flush valves are installed and powered. Most of those are battery nowadays. They can be powered by electricity, by building power. So you just need to make sure they're done. Observe that all water heaters, pressure pumps, and other electrified plumbing equipment is installed and wiring is complete. Observe if all pipe connections are complete, including temperature mixing valves. Observe if control systems are installed. Observe if backflow preventers have been installed and tested. Verify that all signage and labels are installed as specified. Verify hot water and cold water faucet connection. Hot should be on the left. Verify hot and cold water faucet handles rotate opposite each other. Normally cold water is clockwise and hot water is counterclockwise. This could change depending on if got a fancy fixture, may not have that. But these are the standards. I mean, nothing irritates me more than to go into a hotel and find that the hot water and cold water move the same way. It's just unsettling, which means, of course, they put the wrong valve in the hot water valve system. Okay, field reports. So every time you do an inspection, you should issue a field report, and your automatic system will make that easy for you. And basically, the field report has a project header of the data. It has a daily report here of exactly what site conditions were with the day you were there. Description of all the issues you found. Picture of the issues. Remember, pictures are very, very important. If you have something that's unpicturable, which I can't think of anything would be in plumbing, but if there is, you need to explain it in a detailed way. If required, also list on issue log. So if it's a big deal, then you want to put that down on the issue log. And normally what would happen to me is I may take a picture and put an observation report of every issue I found. Where on the issue log, I may just put the general issue. We have several of these, and then refer the issue log back to the observation report. Construction issue log. Construction does not follow drawings or details. Installation is not correct. For installation industry best practices, this could get a little iffy, but if the contractor has a guy on the site who doesn't really know what plumbing quality is, he may not know. So you need to be there for that. For required access, make sure you can access what needs to be accessible. For operability, maintainability, and functionality, can we actually deal with this? Can the operators actually deal with this piece of equipment or this installation? Coordinate with other trades is required. Always put in form of a question, just like any other issue log. And here's again a copy of a construction issue log. Here's the issue. Here's the response, date, and who responded. And this describes where it's located, where the drawing said it should be, or spec. And this is your issue. And this should be a standard issue log, not a big deal. So plumbing commissioning after construction. So create functional test scripts, perform functional tests. Now remember, the functional test is always critical scope because it's a critical path for a construction job. Because functional tests have to be done once the job is 100% complete. Now it doesn't have to have paint, all the painting touch-up done. That doesn't matter. But what does matter is that the craft you're in is 100% complete, and then it needs to be prior to occupancy. So that's why it's critical path. It needs to be right in that performance. So functional test scripts and complete test scripts. Some examples of a plumbing functional performance: verify sequence of operation sensors on faucets and toilets. Manual observation. Now what happens is when they installed a touchless faucet, it needs to be adjusted for how many feet it detects and turns the water on. So you know that it's irritating to go up to a laboratory, put your hands down, and nothing happens. You know, wait a minute, this should have told me that, and you can't seem to get it on, and finally it comes on. Well, that means it's not adjusted correctly. Or if you walk down the stream and you see it comes on and you're not even near the fixture, it can be a problem. So what you do is during a test, you just list the fixtures, and you walk in and approach the fixture. Your hands down. If it doesn't come on, it's not adjusted correctly. Now, there is one key piece of advice. Do not wear your vest with reflective tape on it, because that'll screw them up. Those indicators will pick it up 5 or 6 feet away. And that's not right. You don't want to do that. You want to make sure you wear civilian clothes for that one test. Take your vest off. Do these tests, put your vest back on, because the strips, reflective strips, will mess up your test. Verify actual hot water temperature at fixture and mixing valves. Verify automatic control sequence of pressure pump systems. Test somewhere between, you want to vary the pressure, put it up 10 psi, down psi, and the data trend the results to make sure the pressure system is doing its job correctly. Verify operation and flow of sump pumps and sewage ejectors. That's pretty easy. You just put enough water down there to make sure it comes on and alarms to the different stages, so you can test those controls on the sump pump. It's a manual functional test, but it's still a functional test. Verify actual operation of irrigation controllers. Make sure the control timers work. They're on the right amount of times. Verify automatic control sequences of water softener systems. Test at 0 hardness. Test at 2 ppm and 4 ppm. Manual observation from water hardness measurement. So that's still another manual functional test. Verify operation of any system alarms. Some examples of functional tests. Verify calibration automated reporting water meters. Verify control of gray water systems, manual observation. Verify control of landscape watering systems. Plumbing control process control systems. These control systems are commissioned the same way HVAC controls are commissioned. And if you need to understand how to do that, you need to go watch the commissioning videos for HVAC. Use standard HVAC control, PFD, and FET CX procedures and check sheets and forms. Plumbing commission and final activities. Create commissioning report, executive summary, listed outstanding issues not addressed. The final plan, copies of all inspection reports, copies of all issue logs, copies of all contractor completed PFDs, copy of all functional test results, copies of all CX correspondence. So that's the report. Review O&M manuals. Verify O&M manuals for the exact equipment provided. Verify startup operation shutdown instructions are included for both normal operations and emergency operations. Verify maintenance instructions with suggested maintenance intervals are included. Verify that any required list of spare parts are provided. Create a plumbing system manual. Table of contents, list of contractors and supplier, contact information, facility operating guide, copies of key approved submittals, copies of final approved plans and specifications, copies of pertinent O&M manuals. Training agendas and schedule. Create training agendas as approved by the owner and general contractor. Document owner trainings, events, meet specified conditions, and meet the owner's needs. In other words, a lot of times an engineer will just put in and give 2 hours of training. Well, if this happens to be a piece of equipment the owner already has 20 just like it, he may not need any training at all. But if it's something new and none of his people have ever seen one, he may need more. So you need to check to see what he actually needs and make sure you've changed those modifications somewhere during the process to actually meet what he needs. Provide training sign-in sheets for proof of attendance. Videotape training if contracted to do so, or verify the videographer has completed the tasks. So doing videos are not hard to do. They just take a guy full time to do it during the training process, and you have to have the equipment to do that. So the warranty phase, what that's all about. Well, plumbing commission warranty activities, you create a deferred functional testing, perform deferred functional testing. There may be some deferred tests that couldn't happen during construction. They do it later. Maybe it's off-season test, or maybe something wasn't going to be done or whatever. And you do those during the actual occupancy. A warranty visit, normally 10 to 12 months after occupancy. You view any outstanding warranty or functional issues, commissioning report addenda, update the issue log. This is pretty easy to do. I would basically call the owner and see if he had any outstanding issues. If not, I go to the general contractor and ask for a copy of his warranty log. It's painless for him to give you it. It just says, what kind of issues did you have? I wasn't aware, so I'd like to see it. And you give that, and you put it in, and you just make sure that none of these issues this contractor had were actually a result of something you missed. If it was, you need to go look at it again just to make sure. And then hold a lessons learned workshop. This is where you go meet with the owner after it's all done and say, well, Mr. Owner, how did it go? Was it a good process? Did you think you benefited from it? Did I do a good job? And just ask those questions. And not required by any standard. It's not required as a part of any commissioning process. It's the best marketing move you'll ever make, because really what you're trying to do is sell that customer another job. Remember, in commissioning, you're always looking for customers who have lots of buildings, because the commissioning process, sales process, is long and hard. And so you don't want to waste a whole bunch of marketing and work and efforts on one that only has one job. You need someone that has lots of jobs. So Lesson Learned Workshop helps you build a rapport with the owner and to make sure you don't have any errors or you need to do things differently to help keep him as a customer. Update the Cx report for any warranty activities, and that ends the warranty activities. And that's the end of technical commissioning and plumbing. I hope that was beneficial. I hope you learned something. Really appreciate you watching the videos. Have a great day, and I'll catch you on the next one. Thanks.